Hi, and welcome to the next video in our series on how to do your first DirectX 12 application in C++ from scratch. Um, I've decided to do a few more videos where we implement so-called planar shadows, which are basically shadows that are shown on a predefined um, plane in object space. And I'll also do a subsystem of the application which will handle a time step. And then I'll, of course, fix the long-standing bug in terms of a custom move copy operator on the D12 resource. As you might have seen in the last episode, there's a bug in that system that needs handling, but it's not a critical bug and it doesn't result in any problems right now. So we will do that in the end. Okay, but this episode will be episode 24, and we will create a pipeline that uses stenciling and blending. So stenciling is sort of a way that the pipeline can use um, um, the depth and stencil buffer as a resource where it can store information on whether a pixel should be drawn or not. For instance, is it already drawn or not? So that's basically a buffer that we can write to whenever we render some pixels. So in order to support our stenciling, we need to change the formats of our depth buffer since it's no longer only a depth buffer, it's also a stencil buffer. So let's see, what was the old, whoops, okay, dxgi, b format, of course, b, then 24, and a 8-byte uint. We will simply combine the two buffers and reduce the bit range of the depth stenciling. We will lose a bit of accuracy in terms of depth buffering, but it probably won't matter. Otherwise, we could use the format where we keep the 32 floating point bit resolution on the depth stenciling, but we would have to allocate a buffer that had some padding for the stenciling. We won't be doing that. All right. So we will change that since we initialize a not a yeah, right here we also need to change our format for our depth buffer since it's now using a stencil buffer as well. And I think this should compile and run. Let's see. Okay, we have a problem. Now, let's see. Oh, let's see, pipeline state. Okay, we probably need to change it inside the pipeline state as well. Let's see, depth, stencil, format. Yeah, there we go. We missed that one. Okay, everything simply works again. So now we have changed our format and allowed us to do stenciling. This clearing here is basically the same. So we don't need to update that method. It will immediately support future stenciling. But we would like our pipeline state to be able to initialize in a different state here. So we will we could write a switch here. I prefer to maybe separate the code, initialize as transparent. Let's make an initializer that does exactly that. ID 3D12 device pointer, and we will do a bit of restructuring here because we will also use different shader programs for this pipeline, since this one is probably fine, but we sort of do different stuff here in the pipeline. We don't want to toon shade our shadows. They should just render as a base texture with a or rather a basic material of black with a transparency that we can set through the material itself, and it should simply just use that material to render the pixels. So we want a separate set of shaders for that. So inside our shaders folder, we want to do a separate series of shaders. We will create some shader files here. We don't care what the name is. We just want to name them. Whoops. Okay, well, that came with some information here as a template. I didn't know that, but we will do a void main one here, and of course, maybe we should even just copy our vertex shader here. I don't know if we want to use the normals. I don't think that it's needed, although, yeah, I'm not sure that. Well, the input will be the same buffer, so we will have the information, but we probably don't need to pass it along. Let's exclude this from our build and create a pixel shader. Which we also exclude from our project. And we will simply copy parts of our current pixel shader. We will instead return the material itself. So we won't need the pass data or the light data. Actually, let's clean up this. We don't want the normal to be passed along. We don't care about that. We just don't want to reshape our buffers. We just need the screen space coordinates. So let's adjust this vertex shader here. Let's see. Okay, this is our original vertex shader. Okay, we simply close that one. We could do separate naming or a comment at the top to indicate what we're actually doing here. Let's see. Let's discard the normal. Okay. So this allows us to use different shading for the shadows. So we basically want to duplicate this initialization step, but adjust it accordingly. So instead, we want to compile with our P shadows shadow shaders here. And for now, we will set the exact same stuff here in our pipeline. Whoops, and we will adjust it eventually. But in our renderer here, we will do a pipeline that is plan shadow pipeline. Maybe just a transparent pipeline, because no, let's do a planar shadow pipeline, because we might want to signal that we're using specific methods for exactly this pipeline here. So we will initialize it where we initialize our pipelines, initialize as transparent, and we want to get our device here. And let's see if everything compiles and runs. We have no problems. So now you can see in our console here, we actually loaded the shaders successfully. So that's great. Now we need to set up our pipeline here to, for one, write a stencil buffer so we don't overwrite our or write to our shadows again, because we don't want to. Or maybe I should start with the blending, because uh, we want to render a transparent material, which means it's supposed to be blended together with the existing pixel on our render target. I'll show you in the debugger when we actually do the drawing how it's connected. But we wanted to be blended on top of whatever we have drawn, since we want it to be somewhat transparent, and we want it only to be darkened where the shadow is cast. So we will enable blending for this pipeline. We will not use logic operations. And we will specify this blend state here. We need to pass in a series of let's see, do some blending on the source blend color, which we will set to our source alpha here. Let's see. Source alpha, and we want to set the blend factor for the destination. destination blend to be the inverse of its alpha value. Or rather the inverse of the source alpha here. And we want to add them together. The inverse means 1 minus the alpha value, and render target blend operation here. Let's do add. So this means that our source color gets multiplied by source alpha, and our destination color gets multiplied by the inverse source alpha, 1 minus source alpha. And then we simply add the colors together. And let's see, maybe I'll run into trouble if I don't define the, let's see, render target blend description here. Default values. Do we have any default values? Source blend alpha, blend 1, destination blend 0, add 1. Yeah, okay, it probably gets clamped to 1 anyway. Yeah, so we probably don't need to set that. But we maybe we have to set some alpha blending, but probably not. Okay, so that's our blend factor. This means that the pixels will be blended depending on the alpha channel of whatever we have as a pixel output from this uh, um, pipeline. Which means that whenever we have drawn our scene, we can do another pass with all the geometry through this pipeline, and then shadows will be calculated in the pipeline itself, and each pixel for a shadow will be blended with whatever we already outputted to the render target, and the original color will be added together with a percentage relative to whatever material alpha we have for this pipeline here. We will of course have to do the actual rendering of the solid geometry beforehand. Otherwise we can't really um, do anything. We will be trying to blend shadows on something that isn't drawn yet, so we will do that. We will have to be mindful of that. Okay, down here we can do our depth stenciling, because since we're doing the blending itself, it means that if there's already drawn a shadow, but for some reason another shadow were, or rather, yeah, another shadow from the object itself were to be rendered, because the algorithm decided that a certain vertex resulted in a shadow, and also another vertex resulted in a shadow, and the pipeline wouldn't know that multiple vertices had resulted in the same shadow. You don't want them to be added together, so therefore we will do depth, or rather stenciling. So we will tell the depth stencil state that we will enable stenciling. We want to set it to a depth stencil read mask, which means what values in the buffer, which is remember an 8-byte integer. So how many of those, or rather, which bits of that byte, or those 8 bytes, or rather, no, it's 8 bits, so it's 1 byte. But how will we handle those 8 bits? Will we read all of them, or will we only read parts of them? This allows us to store different information in our stencil value, where we can do specific reads in terms of the bitwise operations, or rather how we use the byte itself. So yeah, imagine that you wanted to not only to have um, um, one layer of stenciling, maybe you wanted a different uh, um, bits set in the stencil. For instance, maybe you want to calculate whether to draw special lights on a surface, and you want that information to be stored in your stencil. We could do that, as well as handle the actual shadows in a different bit of the stencil itself. So, but right now we will use the whole byte for the same information. We don't care. Let's do a uh, uh, let's do a depth font face handle, which means front facing polygons. How should they be handled in terms of the stencil? If we first define the function that we want to use, we want to check if the stencil value is equal. Which means that if we, for instance, have a 0, we will receive a true. If we have a 1, we we would not have a true. So let's see here. If we succeed this check, what will we do? We will increase the value by 1. So the first time that the value is 0, we have a situation where this results in true because nothing has been written to the stencil. So we increase it. The next time we want to consider that pixel in the buffer, we have a value of 1, which means that this will result in false, and we need to set up how to handle if the operation fails. And we will simply just keep whatever is in the buffer, because we will ignore this pixel because it's already written. We could set up the same thing for the back face here. But we also need to tell the system here, what if the depth fails? Well, you can do different interpretations in terms of if the depth check fails, which is defined up here. Maybe if it's needs to be discarded since it's not within the depth. Yeah, you might want to change the value. So if the depth check fails, what would you like to do? Well, we will just keep it. And we will just keep the value in this stencil buffer. You could discard it. Maybe you don't want to. For instance, if we were doing bloom effects, maybe we would know that this area is not visible, so there's no point in setting up a stencil in terms of where to do bloom. So yeah. Anyway, we could also set up the back face, but right now we are doing, let's see, aren't we doing front face calling? Well, we can do front face calling here, or rather back face calling, so we don't do, let's, whoops. Okay, we have a error here that we need to check out anyway. I meant for this to be backface calling here. Let's do that. Well, okay. Let's do front face calling instead, maybe. Okay, the faces are drawn in the wrong order, I immediately see here. So this actually probably needs to be the back face. Let's just set it since we do the exact same thing here. This depends on our culling method. Right now, our imported model from Blender is actually front face cold. Let's see. Let's see, did I specify something that was wrong here? Uh, hmm. Oh, it complains that we haven't set up the default alpha handling here. So let's see what was our, let's try setting, oh, maybe it's all, it's all 0 initialized. So yeah, of course, we need to set that as well. So let's do that. Let's do the alpha, the source blend alpha, the destination blend alpha, and then the blend operation alpha. And let's just set that to this for now. Blend 1, 0, and then add. There we go. This should remove the error. There we go. So I think our pipeline is now set. Let me just play around a bit with these pipeline settings. Let's do this to true because of the winding order, and then let's do backface calling here. And let's just test out flipping all of these vertices here. So instead, this will be 2, this will be 1, this will be 5, and this will be 3, because that's the way the face values were. Let's just try to use the native format for the Blender model here. 9, and then we need to flip these 14, 12. Whoops. Wait a minute, there we go. And then we have our 20, 20, and 23, and 21. All right, right now we are doing you might see that the winding order got messed up. Wait a minute, these don't need to be flipped. These are fine. These are our unique vertices. Here we go. Okay, that really didn't work out. Let's see. Did we mess up some of these settings here? Okay, let's change it back. Never mind. Yeah, because we also reference them. So basically, this pertains to our winding order instead. If we flip these though, well, we exported to the right coordinate system, so the normals shouldn't matter. Okay, this is basically just the winding order that we're toying around with. So let's see if we're doing front counterclockwise, we get a back called mode. So we will do the same thing here. Inside this, true. It's just the way that Blender does the winding order. And we just need to match them between pipelines because we're using the same vertices. All right. Let's compile that. We do have a crash here. Inside our release. Why do we get a crash? Is it because we haven't initialized things now? We should have initialized. The root signature is null. These shaders here. Let's see. Let's just do a breakpoint. Let's see what's happening whenever we arrive at this state, because that's where we have the crash. Uh, well, I don't know how we happen to end up in that state. It's obviously pertaining to the life cycle of things. Let's see, do we have any no, now we don't have any problems. Okay, so if we if we close the application too fast, or maybe it's just random. Now it's working fine. Maybe it's just a debugging layer. Maybe it's maybe we want this function actually. Yeah, it may be more stable. It's because we don't want to the bytecode itself will be potentially a pointer. Is that it? I think we might have fixed it. So if it's ever set to something, we of course release it. Otherwise, we don't care. It might be in a semi-set state. Okay, that's the problem that we were trying to find. Okay, so that's a minor bug fix, as well as the um, pipeline implementation for our shadows. So that's basically it. We created a separate pipeline that will write to the depth and stencil buffer in terms of whenever it's written a pixel, we will render stuff with this pipeline here after we have done our solid geometry. In the next episode, I'll show you how to implement the actual shadow objects. Yeah, so hopefully you found this helpful in terms of implementing a separate pipeline. If you did, feel free to comment, like, or subscribe. Yeah, hopefully I'll see you in the next one. Bye bye.